Apollo 11 is the first manned lunar landing. Took place in July of 1969. Buzz Aldrin, Michael Collins, and Neil Armstrong. 3 astronauts. They landed on the moon. They collected soil samples, rock samples, and then they took off and came back. The mission was funded by NASA, took place on July 16, and it came back on the 24th. 8 days. But we're going to look at these 8 days in a different way. And I'm going to borrow on Einstein's general theory of relativity, or special relativity. A weak field, time is faster. A weak gravitational field means the gravity is low. In a strong gravitational field, time is slower. Strong gravity, slower time. Weak gravity, faster time. Why is this important? Because gravity curves space-time. That's the gravitational effect. And it changes not only the perception of time, but it changes the flow of time. Gravitational effect. So gravitational time dilation. So why is this important? And what's the connection between Einstein and Apollo 11? Well, most people know that the gravity of the moon is less than the gravity of the Earth because the moon is smaller, because the moon has a different kind of orbit, right? And that's the Earth, and this is the moon. This is the new moon. We call it a new moon. So the moon will travel around the Earth every month, right? New moon, from a new moon to a new moon. We've all heard the term new moon. It travels about every 27 and a half days, roughly 27 and a half days. But as the moon is traveling around the Earth is traveling around the sun. The Earth travels around the sun every 365 days. That's our year, 12 months. That's because the Earth travels around the sun every year, and then you have the moon goes around the Earth. But as the moon goes around the Earth is also traveling. And in order to catch up, it's about 2 days. So it takes the moon 29 and a half days to go around the Earth. And that's your moon. That's your new moon. If I go to the moon, I'm going to experience different gravity. So the gravity on the moon is 1.62 meters per second squared. Right? Gravity is what pulls you down. When you drop something and that the speed of the rate it falls, that's basically gravity. Without getting scientific, the rate of fall. It's that pull. Everything has gravity. Anything with substance or matter or mass has gravity. The moon is smaller. It's about a quarter the size. And it's 250,000 miles from us. And it has 1.6, a gravity 1.6 meters per second squared. The Earth, because it is bigger, has about 9.8 meters per second squared, or 9.81 if you want to get exact. Significantly more. So remember that when you have low gravity, time speeds up. And when you have heavy, high gravity, or strong gravity, time slows down. I'm not a scientist. Basically, now we're boring on Einstein's theory of relativity. If it holds true, if Einstein was correct, and he's been proven to be correct, then when I go to the moon and I check my watch, it's going to be faster than the guy on the mothership or on the Earth. In fact, it's a lot faster, because one day on the moon is equal to 29.5 days on the Earth. If you go one day on the moon, it's 29.5 days on the Earth, because that's the moon. Remember, the moon is going here every month. It goes one, and then over here it goes another one, and then over here it goes again, and then over here it goes again, and then it goes. Well, the Earth is just making one orbit. So each day on the moon is 29.5 days on the Earth. In one day, there are 24 hours. 24 hours in a day. So, if we say 1 hour, how much is 1 hour? How much time will elapse on the Earth if I stand on the moon for 1 hour? And that number is, if we use our calculation, 1.23 days. Right? So what 1 hour on the moon is 1.23 days on Earth. And this is the moon. Now, why is this important? It's important because Apollo 11, let's change over here. It's important because Apollo 11 left on July 16. Right, this is all 1969. July 16, 1969. They arrive at the moon, I think July 19, July 20 to 21. That's the lunar lander. And then they fly back July 24th. Splash. Splash down in the ocean. Right, this is your... So you have a total of 8 days. The mission on the moon was recorded at 21.5 hours. 21.5 hours. Most of the July 21st, they were on the surface. So they descended into the atmosphere. They landed. They rested, they ate, they prepared. They spent 3 hours, about 3 hours on the surface, walking. Neil Armstrong was out there 2.5 hours. Buzz Aldrin was out there for another half hour or something, a lesser amount. So you have 3 hours. The third astronaut, Michael Collins, didn't land. He stayed up. Right? So this is the surface. This is the lunar lander. right? This is your lunar lander. And then this is your module up in the sky. So the lander, you had 2 astronauts, right? And then you have another astronaut. And then the 3rd astronaut is up here. So you have Buzz Aldrin, you have Neil Armstrong walking on the moon, and you have Michael Collins up here. He's still in orbit around the moon. So these guys are down here 21 and a half hours. They're walking around for 3 hours. And this is documented. Everybody knows it's about 21 and a half hours. So the whole mission took 8 days. What we're not adding here is time dilation because of gravity, gravitational field. Remember, the moon is 1/6 of the Earth. So a weaker gravitational field, time is faster. Strong gravitational field, time elapses more slowly. Now we have to change, so we have to update our story, right? Because if we take time dilation into account, assuming Einstein wasn't wrong, let's assume he's right, we have to take 21.5 hours times our rate. So 1 hour is 1.23 days, right? 1 hour on the moon, 1.23 days. So 21.5 hours times 1.23 days is equal to, where's my calculation? 26.4 days. Because of gravity. Science. Gravity changes the flow of time. Not the perception of time, it changes the flow of time. On the moon, the watch goes faster. So you have 21.5 hours on the moon, 26 days would have elapsed on the Earth. If we just took the 3 hours just walking on the surface, it would be 3.7 days. Okay? So these numbers are important. Because the Apollo mission left on July 16. They spent 21 hours, right, on the surface, and they landed July 24th. But we have 26-day difference in time. In other words, when they come back off the moon, when they ascend and exit the lunar orbit and they meet Michael Collins would be 26 days minus 21 hours, right? So it'd be about 26.4 days minus 21.5 hours. So he'd be, let's say 25 days. Let's just round it without getting into calculations. Michael Collins would have aged 25 days. And everybody on the Earth would have aged 25 days. If time dilation holds true because of gravity. Because lunar gravity and Earth gravity. So what happens? We are off by 25 days. We have to add 25 days to our mission. So instead of July 24th, it would be July 24th plus 25 days. Right? When they returned, our clocks would read August 19th. Because the time dilation on the moon. In other words, they spent 21.5 hours on the lunar surface. But off the surface, 25 days elapsed, right? 26 minus the 21 hours. So I'm on the lunar surface. I spent 21 hours on the lunar surface. My friend, Mr. Collins, he's waiting for me for 25 days. Or 26 days, right? So he's a month. He's waiting a month for us by the time we come back. He's older by 25 days. If we add 25 days to the July 24th landing in the ocean at the end of the mission, it would be August 19th. If let's say we only added the 3 hours, we would add the 3.7 days, which would be about July 28th. So those are the two. August 19. Oh. August 19 versus July 24, or July 28 versus July 24. Now, July 28 is a conservative. Let's say some of my calculations are wrong, and let's say the only time dilation was when they touched the surface with their feet, because they were on the surface for many hours. In the lander, they were still on the surface. But let's say, because you touch the surface with your feet, time changes. So the minimum time difference, the minimum time shift would be 4 days, about 4 days. So they would have arrived on the Earth at the very earliest. The earliest they should have been back was July 28. So they were back 4 days too early. In the more common sense, if we apply Einstein's theory of gravitational time dilation, they would have come back August 19th. Again, on the surface, they're only there for 21 hours. But time is elapsing differently on the Earth. By the time they get back here, hey, it's August. Where you been? We just went on the moon. So there is a problem. The problem is NASA and Einstein. Now, I hope I'm not distorting Einstein's theory. I'm not an Einstein specialist. But if I follow basically Einstein's special relativity or his theory, they should have come back August 19th, according to NASA, according to Apollo 11 and the astronauts. According to our clocks here, we saw them come back July 24th. Which means what? Which means if they come back July 24th, it means no time dilation. There was no time dilation. So what does that mean? It means no, so that's 1. 2, no gravitational effect. No time dilation, no gravitational effect. What else does that mean? It means that the gravity of the moon is equal to the Earth. There's no time dilation. The ratio is the same. It's a 1-to-1 ratio. 1 hour on the moon is 1 hour on the Earth, which means the gravity is the same. Gravity of the moon is the same as the Earth. There's no gravitational effect. There's no time dilation. That's what Apollo 11, that's what all the astronauts are saying. That's what NASA is saying. And when they splashed down on July 24th, this is what they've said scientifically. They've said that basically Einstein theory is wrong. Apollo 11 says Einstein's theory is wrong because there is no gravitational time dilation. A weak gravitational field and a strong gravitational field has no effect on time, space-time. That's what Apollo 11 is saying. But the question is Einstein wrong? Well, most people say Einstein is right. So most scientists have proven his theory to be right. How about gravity of the moon is equal to the Earth? Well, science has told us that the moon is 1.6, the Earth is 9.8. So that's wrong. No gravitational effects. If that means Einstein's, so that's wrong too. No time dilation, that's wrong too. By landing on July 24, this is what they're saying. And they should have arrived, if they landed here on August 19th, then there'd be no argument, because time dilation is... Unfortunately, this is what's happened. It means Einstein's wrong. It means the gravity of the moon is equal to the gravity of the Earth, which is wrong. Or it could mean this. If the gravity of the moon is equal to Earth, what does that mean? It means that the moon, if the moon is equal to the Earth, that means the moon is the Earth, right? Because if the gravity of the moon is the same as the Earth, then all the science is wrong. Which we also know the moon is a quarter size of the Earth. Einstein's theory has been proven, but according to Apollo 11, all of this says the moon is equal to the Earth, which means there's no moon. The moon is equal to the Earth, means that there's only the Earth. Which means they did not leave Earth. They did not leave Earth. If the time effect is a 1-to-1 ratio according to the Earth, according to the gravity of the Earth, and they were gone 8 days, and they came back after 8 days, no time dilation, then they did not leave the Earth. They did not go to the moon. If they went to the moon, they'd have gravitational effect, different gravity, different time dilation. Einstein is right. If Einstein is right and the Apollo 11 took off, they didn't leave the Earth, which means they went into the low Earth orbit, which can be thousands and thousands of miles up, but they did not leave the atmosphere. That's the conclusion. They stayed in the Earth's atmosphere, because then you have the same gravitational laws, and the time dilation in low Earth orbit is seconds. You know, you might lose a few seconds or a few minutes. Your watch might go faster a few minutes or a few seconds, but you're not going to have a major distortion of time. So you got back after 8 days. So they only could have gone into low Earth orbit or upper atmosphere. They did not leave the Earth. The second option is they went to the moon, right? This is the Earth. This is the moon. So they leave here, they fly around the Earth, and they zip over here. The second option, so it's either they flew here and they just flew around the Earth for 8 days, or it's possible that they flew to the moon and they flew around the moon and then they flew back. They didn't land. Which begs the question, where did they land? If they didn't land on the moon, because no time dilation, no gravitational effect, and if Einstein's right, they didn't land on the moon, but they have pictures, we have video of them landing on the moon. So where did they land? Well, they were gone 8 days, and the mission was 8 days, or Einstein's wrong. If they landed on moon, okay, it's just a summary here. If they landed on the moon, then Einstein is wrong. And gravity is equal to Earth. The gravity of the moon is equal to the Earth. Einstein is wrong. There's no time dilation. If they landed. And we have pictures of them landing. But we know Einstein is right. And we know gravity is not equal. We know these things to be true. And there could be other details we're skipping over here, but Einstein is right. Gravity is not equal between Earth and the moon. But they have pictures of landing. They couldn't have landed on the moon. Where did they land? I don't know. But they didn't land on the moon. If they landed on the moon, Einstein is a moron. And if they landed on the moon, the gravity on the moon is the same as the gravity of the Earth. Among the other things we discussed. So where did they go?